Today we're going to look at some more things that Desmos can do for us. What we've done most of the year so far is look at functions from equations and turn them into points on a graph and then maybe connect the dots and make a shape out of it. Today we're going to go in the other direction. We're going to go from the dots to the equation, or from the coordinates to the equation. So let me give you an example. I'm going to put a bunch of coordinates into Desmos, but what's important is that I put them not as separate coordinates, which if I wanted to, I could plot a coordinate like that in parentheses, but I don't. I want to put them in as a table of values, so that way they're organized together. I'm just going to put a bunch of coordinates in here. -4, -2, -3, -5, -2, -6, -1, -5, and 0, -2. Now you might see the shape that I've made here. Recognize that, hey, that looks a little bit like a parabola. Great, glad you noticed that. What we can do, though, is have the calculator, have Desmos, figure out exactly what equation made that set of coordinates. We all know that a parabola, or a quadratic function, is y equals a times x squared plus bx plus c. We know that. Now, I could put a bunch of sliders in here and then try and move things down to make this work, and then I could move this backwards a little bit. And hey, that seems to be pretty good, but that's not very reliable. So what I want to do instead is tell Desmos to use these y values, which aren't just any old y values, they have a specific name called y1. So I'm going to tell Desmos to use the numbers in y1. You don't have to do anything special to make that 1 be small. If you just press the number 1 right after the variable y, it'll be a small y for you. And instead of the equal symbol, when we want Desmos to figure out the equation for us, we use the tilde symbol. It's on the keyboard next to a 1. It's on this keyboard also, somewhere. I don't really know where. There it is, this guy. But what I want you to do is use the keyboard anyway, because I actually hate that keyboard button. Use the keyboard on your actual computer, and you have to press Shift and then tilde. And then you can tell Desmos exactly what format you want. Instead of using sliders for A, B, and C, just use the letters A, B, and C, and Desmos will figure out what equation to put in there. So if we want to use ax squared plus bx plus c, we can do a times x squared, except just like the y1, the y values, we had to tell Desmos specifically to use the y values from this table, so we had to call it y1. We want Desmos to use the x values from this table also, so we're going to call it x1. Y equals a times x1 squared plus b times x1 plus c. And it is able to figure out exactly what the a, the b, and the c need to be in order to make this equation match. Sometimes, though, what we're going to do is not necessarily an exact perfect parabola. When you have real-world data, even things that are generally like a parabola aren't always perfect. So let me give you an example. Let's say you are draining water from a water bottle. You put a hole in the bottom of a water bottle and you drain the water from it. The water doesn't flow out in a steady stream, like the speed at which the water is coming out changes. Let's say you would have a stopwatch, and you'd be measuring how much time has gone by. We'll call that x1 as time. So maybe every 20 seconds you measure the depth of the water again. And so you do it for a couple minutes here. And then at each one of those 20-second intervals, you measure how deep the water is. And let's say these are your numbers. I'm getting these numbers, I'm getting these numbers from a chart. I'm not making them up off the top of my head. So notice what's happening is because the water is draining out, the depth keeps getting lower and lower and lower. But you might also notice that it's not dripping out as fast anymore. The less water there is in the bottle, the less pressure there is or weight making the water come out. So the water is going to slow down. Okay, so I want to look at the graph of this. You've seen me talk a million times about how zooming in and zooming out is not good. Like, that's not very useful. In this case, though, because we have the numbers in front of us, it definitely makes sense to just go to the graph settings button here and type in the numbers that you want. On the x-axis, we're measuring from 0 seconds to 220. If you want, you can go a little bit to the side so you have a little bit more room. And we're measuring time. So you can either say time or seconds or both. And on the y values, we can see we get as low as about 30 centimeters and as high as about 42. So I like to see the floor. So you certainly could go from 30 to 45, but I'm actually going to go, I like to see the x-axis. So I'm going to go from negative 10 to about 50. And we'll label this as depth of the water in centimeters. And so here's my graph. And so we can see this isn't quite a straight graph. Once you've made your graph, from there, you can like move around. It's a lot easier once you've made the shape generally right. And if you see, if you zoom in like this, you can really see it's kind of got the shape of half a parabola. So I'm going to see if I can make a parabola that fits through this pretty well. And this is where I'll use the same format that we used in the last example. When you're doing this for real-world data, it's called a regression. Regression. It just means you're trying to fit an equation to real-world data. I'm going to set it up the same way I did before. y1 is approximately equal to a times x1 squared plus b times x1 plus c. And it did a pretty good job of fitting it in. This is almost a perfect parabola. Notice how some of the dots miss by a little bit, but mostly it goes through pretty smoothly. And then down below, it tells me the A, the B, and the C that it calculated. I would have never guessed these numbers, obviously, but these are the numbers that would work if you would type it out. Y equals 0.000210352 x squared minus 0.0103428x plus 42.6541. You would get this exact parabola. Note, by the way, you could have done this in a different form too. If you wanted to, you could have asked for it in vertex form, a times x1 minus h squared plus k. Notice how it's the same exact a, but it would give me an h and a k instead of a b and a c. You can choose whichever method you want. So this is what's called a regression, and this is how you set it up on Desmos.